The key to success lies in recognizing a crucial factorization that transforms an impossible problem into a manageable one. Here's our integral. At first glance, this looks extremely difficult. We have a cubic polynomial multiplied by another polynomial raised to the 2021st power. The secret lies in this first polynomial, x cubed minus 3x squared plus 2. This polynomial has a special factorization that will unlock the entire problem. Let's factor x cubed minus 3x squared plus 2. We need to find its roots to determine the factorization. Let's test x equals 1. 1 cubed minus 3 times 1 squared plus 2 equals 1 minus 3 plus 2, which equals 0. So x equals 1 is a root. Since x minus 1 is a factor, we can perform polynomial division to get the complete factorization. X cubed minus 3x squared plus 2 equals x minus 1 times x squared minus 2x minus 2. Now we can substitute our factorization back into the original integral. The x cubed minus 3x squared plus 2 becomes x minus 1 times x squared minus 2x minus 2. Notice something important. When we substitute the factorization, the exponent changes from 2021 to 2022. This is because we now have x squared minus 2x minus 2 raised to the 2021st power, multiplied by another factor of x squared minus 2x minus 2. The exponent increases from 2021 to 2022. This transformation is the crucial insight that makes this integral solvable. Without this factorization, the integral would be nearly impossible to solve. This single insight transforms an intractable problem into one that can be handled with the right substitution technique, which we'll explore in the next section. Now we'll use substitution to evaluate our integral. We define g of x equals x squared minus 2x minus 2. Taking the derivative, we get g prime of x equals 2 times the quantity x minus 1. Solving for the quantity x minus 1, we get x minus 1 equals g prime of x divided by 2. Now we substitute this relationship into our original integral. Substituting into our integral, we get 1/2 times the integral from -1 to 1 of g prime of x times g of x to the power 2022 dx. Using the fundamental theorem of calculus, this simplifies to 1/2 times g of x to the power 2023 divided by 2023, evaluated from -1 to 1. Now we need to evaluate g of x at our limits of integration. At x equals -1, g of -1 equals -1 squared minus 2 times -1 minus 2, which equals 1 plus 2 minus 2 equals 1. At x equals 1, g of 1 equals 1 squared minus 2 times 1 minus 2, which equals 1 minus 2 minus 2 equals -3. Since 2023 is an odd number, we have -3 to the power 2023 equals -3 to the power 2023. Now we can substitute these values into our expression to get the final answer. Substituting our values, we get 1/2 times 1 over 2023 times -3 to the power 2023 minus 1 to the power 2023 over 2023. This simplifies to 1/2 times 1 over 2023 times -3 to the power 2023 minus 1. Therefore, our final answer is -3 to the power 2023 plus 1, all divided by 2 times 2023. This solution demonstrates the power of strategic substitution in simplifying complex integrals. By recognizing the relationship between the integrand and a suitable substitution, we transformed a difficult integral into one that could be evaluated using the fundamental theorem of calculus.